In this video, we're going to look at an important application of the derivative, and that is of the concept of rate of change. So we're going to look at two types of rate of change. We're going to first look at the average rate of change, and then we're going to look at what's called the instantaneous rate of change. So let's first look at the average rate of change. Now over here I'm going to put down that the average rate of change is just the slope of the secant line. Okay, so just remember that average rate of change is the slope of the secant line. So let's say we have a function f of x. And here's a secant line. And so this here will be x of 1, and this down here would be x of 2. And what we want to do is we want to find the slope of that secant line. Okay, so if you remember, slope is basically y2 minus y1 all over x of 2 minus x of 1. Okay, so to get that, if this is x of 1, to get our y-coordinate, that would be f of x of 1. And if this is x of 2, to get our y-coordinate, we would have f of x of 2. So I'm going to say that this is y2 and this is y1. So the slope of the secant line is going to be f of x of 2 minus f of x of 1 all over x of 2 minus x of 1. Okay, so this is what we're going to use as the average rate of change. So when you see things in a book, it's going to say that the average rate of change equals f of x of 2 minus f of x of 1 all over x of 2 minus x of 1. So this is something that you need to remember, but if you remember this is just the slope of the secant line, slope of secant line, and that's how I remember it. I just remember as slope of the secant line. It makes it a lot easier to remember this. So a lot of students are thinking, oh, that's just another formula. Don't think of this as a formula. Think of it as, well, because I know it's the slope of the secant line, I need y2 minus y1 over x2 minus x1, but we just got to write it a little bit fancier. We just say f of x2 minus f of x1 minus x2 minus x1. So once you think of it as slope of the secant line, it becomes a lot less complicated. Okay, so when do we use average rate of change? And average rate of change is oftentimes used when you don't have an equation. You don't know exactly what's going on. So let's look at an example. All right. So let's say you are driving down the highway. Let's see, you're driving down the highway. You leave, whoops, at 1 o'clock and drive 125 miles in 2 hours. How fast were you going? How fast were you going? Okay, so this is kind of a basic example, but it gives a general idea. If I were to kind of try to sketch this out, so here's time, here is position. Now you start off at 1 o'clock, so we'll say this is 1 o'clock. You're at 0 hours, we'll just say it's 0 hours. And then after 2 hours, so we're at 3 o'clock, you're at 125 miles. And there we go. Now the thing is because we don't have data points in between these, we're not quite certain what's going on. But how fast were we going? Well, you can take the average rate of change. So we say, okay, here's our secant line. And so our average rate of change is going to equal, and so we go 125, we started at 0, and we have 3 minus 1. So 125 over 2 becomes 62.5. So 62.5 miles per hour. And this is going to be our average speed in this case, or velocity. We'll talk about the difference between speed and velocity later. Now, the interesting thing here is that it doesn't say that we've gone a constant 62.5, and for most people that's not true. This is just an average speed. I mean, really, we could have started off fairly slow, we sped up, and we were probably kind of just going back and forth over that line. And there were moments where we were going, the correct speed, or the speed of 62.5 miles an hour. However, in general, we weren't going exactly 62.5. However, that was our average speed. So we actually use average rate of change a lot, in day to day. We just don't think of it like average rate of change. But that's the general idea, average rate of change. Okay, let's look at an example you might get in the book, though. We do have to look at that. So we want to find the average rate of change of, let's see here, f of x equals x cubed plus 1 in the interval from 2 to 3. All right, so, the concept of how to use average rate of change, I'm not sure if you quite understood this. We're going to, we'll use this a couple more times, but the actual process is pretty straightforward, because all we need to really do is the average rate of change is just f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. And so we just have to put in these values. So first we need to find f of x sub 2 and f of x sub 1. So what is f of x sub 2? So that's going to be f of 3. One thing to note, when it comes to the average rate of change, it does matter which one is x sub 2 and which one is x sub 1. So you do have to remember that the second one is x sub 2. So keep track of that. I know in pre-calculus and other courses, we sometimes say, oh, it doesn't matter which one is x sub 2, just as long as we're consistent. And I would say in this class, you do want to keep track. This one would probably work out because it's just slope, but there are times where this being x sub 2 is important. So we'll start doing that. Okay, so this is going to be 3 cubed plus 1. Let's see here, so that's 27, that's 28. And then f of x sub 1 is going to be f of 2, which equals 2 cubed plus 1, which is 9. Alright, so our average rate of change is going to be f of x sub 2, which is 28, minus f of x sub 1, which is 9, all over 3 minus 2. And so this is 19 over 1, and so we end up with 19. Now, because it doesn't have any units, it doesn't make much sense. But anyways, that is our average rate of change in this particular example.